Worksheet number 5, determining pH and titration. Now question 1 to 3, refer to the following solution. 0.1 molar barium hydroxide, 0.1 molar sodium hydroxide, 0.1 molar methanol, 0.1 molar acetic acid, 0.1 molar nitric acid. Neutralized an equal volume of 0.2 molar HCl. Neutralized means number of moles of acid equal number of moles for base. As you know, concentration equal mole per volume. So number of mole equal concentration times volume. So here concentration times volume for acid equal concentration times volume for base. So in the question here, equal volume, acid and base, they have equal volume, so you can delete volume from the equation. So concentration of acid must be equal concentration of base to neutralize each other. So here in the question, the concentration of acid equals 0.2 molar. So you have to find 0.2 molar hydroxide ions. Now here in the choices, A and B are the bases. So for B, for example, the concentration of hydroxide equals 0.1 molar. For A, the concentration of hydroxide 0.1 times 2. So 0.1 times 2, which is equal 0.2 molar, which is equal to the concentration of acid, so they neutralized each other. So the answer is A. Question 2 has a hydrogen ion concentration 1 times 10 to the power negative 1 molar. So here D and E are the acids. D 0.1 molar acetic acid. It's a weak acid, does not completely ionized, but E, it's a strong acid, so it dissociates to gives 1 hydrogen ion and 1 nitrate group. If the concentration of the acid equals 0.1 molar, because it's a strong acid, so the concentration of hydrogen 0.1 molar and concentration of nitrate 0.1 mole. So the answer is E. Has a pH greater than 2 but less than 6. pH less than 7, it's for acid, and between 2 and 6, it's for weak acid. So the answer is D, acetic acid. Now question 4 to 6, refer to the following question solution, aqueous solution. 10 ml of 0.01 molar sulfuric acid, 10 ml of 0.01 molar hydrochloric acid, 10 ml of 0.001 molar hydrochloric acid, 10 ml of 0.001 molar ammonium chloride, and 10 ml of 0.01 molar ammonia. Has a pH greater than 7. Greater than 7, it's for base. So here sulfuric acid, hydrochloric acid, ammonium chloride, it's a salt. So the answer is E. Ammonium is a weak base. 5. After 10 ml of 0.01 molar of NaOH is added, has a pH equal to 7. pH equal to 7 means neutral. Neutral means mole of acid equal number of mole of base. So mole equal concentration times volume. So concentration times volume for acid equal concentration times volume for base. So here in the question 10 ml of the base, and here all have 10 ml, so equal volume. So you can delete volume from the equation. So concentration of acid equal concentration of base. In the question, what is the concentration of base? 0.001 molar. So you have to find 0.001 molar hydrogen ion. So for the first one, the concentration 0.01 times 2, because it contains 2 hydrogen ion, so 0.01 times 2 equals 0.02 molar, not equal to 0.001. The second one, the concentration 0.01 molar, also not equal to the 0.001. Third one, the concentration equals 0.001 molar, which is equal to the concentration of base. So the answer is C. So for question 5, the answer is C. 6. After 10 ml of 0.01 molar NaOH is added, has a pH less than 6. Less than 6 means acidic solution. In acidic solution, concentration of hydrogen greater than concentration of hydroxide. So here the concentration of hydroxide 0.01. So you have to find greater concentration of hydrogen. So here the first one, the concentration of hydrogen 0.02, which is greater than the concentration of base, so it's an acidic solution. The answer is A. Now question 7 to 10, you have solutions here. 0.1 molar HCl, hydrochloric acid, it's a strong acid. And here you have sodium hydroxide, it's a strong base. So when you add strong acid to strong base, they neutralized each other. So solution C, neutral. Here you have acetic acid. Acetic acid is a weak acid. Is added to sodium hydroxide, strong acid. When you add weak acid, strong base. When you add weak acid to strong base, so the solution has a pH greater than 7. So here base, because the strength of base greater than the strength of acid. So now has a hydroxide ion concentration 10 to the power negative 7 molar. If you remember this concentration for a neutral concentration, a neutral solution. If you remember, for a neutral solution, concentration of hydrogen equal concentration of hydroxide, which is equal 1 times 10 to the power negative 7 molar. So which of these neutral solution? C. So the answer is C. Has the highest pH. Highest pH means strongest base. Which of these strong base? B. So the answer is B. Now has a pH greater than 7 but less than 13. So greater than 7 but less than 13, it's for weak base. Here in the solution, B is a strong base and E is a weak base. Why weak base? Because when you add acid to base, the acid decreases the strength of the basicity of the solution. So the answer is E. Now, has a pH greater than 2 but less than 7, it's for weak acid. Which of these weak acid? D, acetic acid. Now part B, CE questions. All indicators are colorless in a neutral solution. False. Indicators develop color only in the presence of a strong acid or strong base. Also false. It can give colors in weak acid and weak base. A solution prepared by adding 15 ml of 1 molar sulfuric acid to 15 ml of 1 molar sodium hydroxide has a pH 7. Again, pH 7 means mole of acid equal mole of base. So concentration times volume for acid equal concentration times volume for base. Here 15 ml of acid, 15 ml of base. So concentration of acid must be equal to concentration of base. So here the concentration of acid 1 times 2, which is equal to molar. The concentration of base equal 1 molar, not equal to each other, so the pH not equal to 7. False. 1 mole of hydrogen ion neutralized 1 mole of hydroxide. True. Now question 11. Which graph could represent the pH of a 0.1 molar solution of nitric acid versus the volume of a 0.1 molar sodium hydroxide that is added to it? This is for titration. If you remember from the handout, so the figure of the plot for titration, it's E. Which of the following statement is true of a solution of 0.1 molar hydrochloric acid? The pH equal to 1. Yes. 0.1, 1 times 10 to the power minus 1 molar. So pH equal 1. So it's a correct statement. The concentration of hydrochloric acid is greater than the concentration of hydrogen. False. Why? Because HCl is a strong acid, so it dissociates to hydrogen ion plus chloride ion. So if the concentration 0.1 molar, the concentration of hydrogen 0.1 molar, and the concentration of chloride ion 0.1 molar, they have equal concentration. The concentration of chloride is equal to the concentration of hydroxide. False. the concentration of hydrogen is equal to the concentration of hydroxide. Also false. The indicator phenolphthalein turns pink when added to acid. No. Phenolphthalein, it has a colorless color in acidic solution. So the correct answer is A. (13) If a student were to accurately analyze mixture of solid sodium chloride and solid sodium hydroxide by titration of the hydroxide ion with a standard solution of HCl, which of the following would be least useful? So for titration, we don't use Bunsen burner, but we use balance to prepare the titrant. Titrant means known concentration. We use burette. We put the titrant in it. We use Erlenmeyer flask. We put the analyte in it. إذن هون titrant. Erlenmeyer flask for analyte. Analyte means unknown concentration. And we use indicator. For example, we use phenolphthalein. So which of these least useful? The answer is A. Question 14. The concentration of hydrochloric acid solution is to be determined by titration with a sodium hydroxide solution. It's essential that all of the following experiment quantities be known except the temperature at which a titration is performed. You have to know the temperature? No. Concentration of sodium hydroxide solution? Yes. You have to know the concentration for calculation. Volume of hydrochloric solution that used? Yes. You have to know the volume of analyte. Initial purity reading and final purity reading? Yes, to get the volume. Then how to get the volume of titrant. And here concentration of titrant. And you have to know the volume of analyte. So the answer is A. Now question 15. The molarity of solution X is to be determined by titration procedure. To carry out this procedure, all of the following must be known except equation for a chemical reaction that occurred during the titration. You have to know the equation to get the mole ratio between acid and base. Okay, volume of the solution X that used. Yes, you have to know the volume of analyte. Mass of solution X that used. No, you have to know the volume. For calculation, you need the volume, not the mass. So volume of solution that react with X, yes, اللي هو volume of titrant from the burette. You have to know it. And molarity of the solution that react with X, yes, concentration of titrant. You have to know the concentration of titrant for calculation. So the answer is C. Question 16. The relative acidities of solution are most often determined by use of. We use indicators to get the pH of solution. Question 17. In an acid-base titration, 30 ml of 0.1 molar KOH was required to titrate 60 ml of a solution containing unknown monoprotic acid. Monoprotic acid, it means it contains one hydrogen. What is the molarity? So keyword هون titrate. So what is the rule for titration? Mole of acid equal mole for base. Mole equal concentration times volume for acid equal concentration times volume for base. So the concentration of acid, you have to calculate it. Concentration of acid time the volume of acid, 60 ml, 0.06, you have to convert it to liter, equal concentration of base, 0.1, times volume of base, 30 ml, converted to liter, 0.03. So concentration of acid equal 0.1 times 0.03 over 0.06. So here the decimal after 2 units and hon after 2 units you can delete it. 3 over 6 half. So 0.1 times half, 0.05 molar. So the answer is B. The last question. Bubbling gaseous hydrogen chloride HCl into distilled water produced when you add HCl to water, so you get solution with pH less than 7 because it's an acid, so decrease the pH.